All right, good evening. It's 8 o'clock, so we'll go ahead and get started. First of all, you have to excuse my voice. I've actually been a little sick today, in the recovery phase right now. So I'll try to speak as clearly as I can. If you don't understand something, just let me know. Also, if you have any question as we go along, you can go ahead and either unmute yourself and ask your question, or you can type a question in the chat box. Sometimes I won't notice those immediately, but whenever I do see them, I will answer your question. Also, at the very end, we will have like a question and answer session if you want to wait till the end, but you don't have to wait until the end. All right, so this is week 2 of the CMIS 102 class, basically beginner Python. So let's go ahead and get started. So first of all, we'll cover some of the stuff that you looked at in week 1. We'll go over some of the stuff for week 2. We'll talk briefly about the assignment, and then we'll open it up for any questions you may have. All right. So first of all, for week 1 was really about learning how to print stuff and how to and what variables are. So a lot of what you'll see me do in this Zoom session, and really all the future Zoom sessions, is I'll talk about a concept, but I'll actually program it right here in front of you so you can see what it looks like. All right. So first, let's talk about print. Print is how you put something on the screen. Whatever you want to print out. You think about it. It derives from the days of actual physical printers where you would print something to a piece of paper long before there were actually monitors. But we can still print something to the screen. And we use it with the keyword here, print. We have the open and close brackets. And inside of here, we have quote marks. You can actually use the single quotes. You can use single quotes, or you can use double quotes, whichever your preference is. My personal preference is single quotes, though. So you'll see me use single quotes a lot. And that's all there is to it. This will let us print out this hello world to the screen. So let me save it. Let me go down here and run it. Let me see if I can increase the font size on this. There you go. It's a little better for the font size. So run my file, and there it is. It prints out hello world. Now, I'm not using Python idle. You are not required to use Python idle. Certainly you can if you want to, but you're not required to. I'm just using a version of Linux and the command line here. But with my Python file here, I just said print out hello world. And when I ran the program, it does indeed print out the hello world. And this can be anything that you want. Anything that you want. And that's exactly what it will print. Let's run it again. And it prints out anything that you want. Now you can have as many words in here as you want, separated by comma. What I mean by that is, now if I put anything and separate words by a column, by a comma, sorry. What happens if I do this? I want to print out these 3 words. What it'll do, it actually prints out anything you want all in one line. What Python does is, between each word or between each thing that you want to print out, it inserts a space by default. So that's why you see it say anything space you space want, and then the end of the line. Python automatically inserts a space in there. So you can print things out like that. And that's the very, very basics of printing. And it doesn't have to be text. You can print out a number. Let's print out, just put in that number there. We run that. You see it does print out that number. Let's print out a different number. And there we go. We have printed out that number. So the print isn't just for text. It's for text. It's for numbers. It's for a bunch of different things. You'll see throughout the entire course over the next 8 weeks. But right now, we're just looking at numbers and text. So that's all there is to the print statement. The other thing for week one that you had to read about is what we call variables. A variable is just a way to, what's the best way to say this? It's to store information that you want to use later. One second, I got a question. How come you didn't need to put quotes around the number, and how do you use quotes for words? That's a good question. Because I said that print, it can print out a number or it can print out text, right? So here I am printing out the number 42. I could do this, but there's actually a difference. If I run that, it's going to print out the same thing on my screen. It looks like it's the same thing, but these two things are actually vastly different. This is the number 42, the actual mathematical and numerical value of 42. And this is just a excuse me. Excuse me. And this is just the text that has the number 4 and 2 in it. This is not equal to the mathematical value 42. It is just the text that looks like the number 42. So there is a difference there. But like I said, when you print them out, they actually print out the same exact way. But you need to know that that is a number that you can add, you can subtract, you can multiply with. This is text. You can't multiply, you can't divide with that because that is not a number. And that's the difference between with quotes and without quotes. And second part of your question, is that because of the ASCII table? No, not exactly. Numbers do have, like this text number, like if we look at 4, let's just leave that. We can print out 4. I think it's ORed 4. Yeah. You probably won't see this too much. But this will print out 4, right? But that is text. Okay. What this ORed does, it's probably not really that important for you guys to worry about right now. But what it'll do, it'll take that text number and it'll get the value out of the ASCII table. You don't really need to worry too much about the ASCII table for this class, but somebody asked. But if I do this, it'll give me the numerical value out of the ASCII table for that. If I run it, I forget what it is off the top of my head. It's 52. Oops. So if you look up the number 4 in the ASCII table, you'll see that it has the value of 52. So that's how the ASCII table can play in there, but you don't need to worry too much about that. You don't need to worry too much about the ASCII table. Just know that the first one is text and the second one is the actual mathematical value 42. Okay, so let's talk about variables. A variable is basically a way that you can store some information that you want to use later. What I mean by that, let's say we have a variable called A, and we want to say it's equal to the text ABC. This A is what we call a variable. It is equal to this text, which is ABC. So now if we print out A here, what is going to get printed out? Am I going to get the letter A printed out? Or am I going to get the text ABC printed out? Well, if I do this, that's going to print the letter A, right? Because whenever I have the quotes there, it means it is text. I want to print out exactly that text. But if I leave off the quotes, I'm saying I want to print out whatever this is. What is A? A is equal to that ABC. Let's run that. And you see, when I print the A, I'm printing out the actual ABC. We can call this the first word. And when you're naming variables, which is what I'm doing right now, I've made two variables. The first variable, the name of it is first word. I've created a second variable. The name of the variable is second word. And I'm saying first word is equal to this text. Second word is equal to that text. All right. Now, when you're naming variables, there's some rules that you have to remember. A variable name can only have letters and numbers in it. You can also have an underscore. So letters, numbers, and underscores. You can't have any special characters. And it has to start with a letter. Actually, I think it can start with an underscore too, but that's nobody ever really does that in the real world. So when you're naming variables, it needs to start with a letter. But it can have as many letters as you want. Let's get rid of the second one. Let's just print out first word. Let's run that again real fast just to show that it works. Run that, and there we go. It prints out my ABC. Let's call it something different. That's fine. Now, that doesn't make very much sense because who's going to be able to remember that? But if I call my variable this and then I print it out, it's still going to work. Let's run it. It still works and prints out ABC. But this isn't very helpful when your variable is a bunch of random letters and random numbers, right? Technically that works, but it doesn't make a lot of sense. Why? You want to name this something descriptive of what it represents. This is going to represent the first word in my program. So I'm going to call it first word. Let's say if I have a number, I'm going to call it pi because I'm going to make it 3.1415927, etc., right? So I have a variable called pi and it's equal to this number. So the variable name, it makes sense, right? If I see the variable pi somewhere later in my program, I'm going to at least have somewhat of a good idea what it represents. If I have, if I use first word later in my program, I'm going to have a good idea of what it represents. So let's print out the first word and then let's print out pi. And we can do it with a comma if we want it on the same line. Save it and run it. And there we go. We get the ABC, which is the first word. And then we print out pi, which is that number 3.14, etc. Right there. So that's what these variables are. They can, you think of them as a placeholder for some kind of data, some kind of information. For this one, I made it be a string. For this one, I made it be this floating point number, this float, right? That number. And you can change them later too. So let's just change this to number. Let's keep these short so I don't have to type as much. There we go. We're just going to have a variable called word and it's ABC. We'll have a variable called number and it's that number, right? Save it and run it. Still the same thing, works just fine. But now let's say later we want to change the word. Now we want to make it DEF. And now we're going to change the number to 42. And now let's print them out again. And that's fine. Your program executes from top to bottom, right? So the first thing it does is it executes this and makes the word equal to ABC. The next thing is the number is that number. Then it'll print them out. Now it's the same exact variable, but we want to change the value of it. Now, instead of ABC, we're going to say it's equal to DEF. And the number, instead of this, is now 42. And then I'm going to print them out again. So let's watch that. And there you go. The first time we print it out, that's what the values are. The second time we print it out, that's what the values are. So what can we do with these variables? Why are these variables important? Let's do all kinds of cool stuff. Let's say we want to add two numbers together, right? Well, 3 plus 4. We could do this. Let's say print out 3 plus 4. What should happen here? It should print out 7, right? If we run it, and there you go. You know, it prints out 7. We could do it with variables. A is equal to 7 and just print out A. That also gets me my 7. But let's say we have A is 4, B is 3. And here we can do A plus B. So your program starts right here. It says A is equal to the value 4. B is equal to the value 3. Here I'm going to add A plus B. Well, A is 4, B is 3. So this is 7. And then it prints out 7. Save it and run it. And there you go. Prints out 7. It doesn't have to be two variables. Well, you can do A plus 1. That's fine. You can take a variable and add it to a number. There's nothing wrong with that. You see I got 5, and that's right. Because A is 4, I added 1 onto it to get 5, and that gave me the answer. I can do that. A plus B plus 53. See, we're doing some math stuff here. That's what we can do with variables. It's very powerful. Let's run that. There you go. It gives me the answer 60. And that's right, because that's 4 plus 3 plus 53 is 60. Okay. So the plus is what we call an operator. There's actually several operators that we worry about. We have the plus sign, which is addition. Let's make some comments here. We have the minus sign, which is subtraction. We have the star, which is multiplication. We have, what else we have? We have the slash, which is division. And we have star, which is exponent. Those are the different ways we can do math. So let's do some multiplication. We'll say A is equal to 5, B is equal to 3, and C will equal A times B. Then we'll print out A, B, and C. We'll print out all 3 of them. What's going to happen here? Well, A is 5, B is 3, so 5 times 3 is 15. So we're going to print out 5, 3, and 15. Run it. There you go. We get 5, 3, and 15. So that's multiplication. Let's do subtraction. Now we should get like 5, 3, and 2, right? Yep, 5, 3, and 2. What else did we not do? We already did addition. Let's just do addition again. 5, 3, and 8, right? There it is. And we'll do exponent last. So this will be 5 raised to the 3rd power. I think that's 125. Let's run it. There you go. So A is 5, B is 3, and the power of those two is 125. Okay. So that's the different operators and how we can do math with them. So this works for numbers. Does it work for the text? When I say text, I'm going to start calling it a string, because that's what the terminology is for really every programming language, and especially Python. We call it a string. So if I have S is equal to my first name, right? So we're going to say it is the string Daniel. S is a string. All right. Let's call this first and call this last. My first and last name, right? So we can do print the first and print the last. And that's going to print my name, right? Well, can we do these math operators with strings? And the answer is yes, but only addition. We can add strings together. And what do we think happens if we add strings together? It just combines them together. It puts them one after the other. So if we run this, so the first string is Daniel, the last string is Steffi. We add them together and it just concatenates them. It combines them together. And then I'm going to print that out. It should print out my name, but without a space in it. And there you go. There is the string added together. We could also add a space in there, right? So this is the first name plus a space plus the last name. If you run that, there we go. That's a better printed name with the space in there. So we can add strings together. Can we subtract strings? Let's see. Let's put first minus last. What happens if we try to subtract strings? Right? Oh, it gives me an error. And that's because Python knows you can't subtract strings. Because if you think about it just logically, what would it mean to subtract a string? There's no real good logical way to explain what subtracting a string even means. Adding a string, you can logically, argue that, well, if you add two strings, combine them together, that kind of makes sense. But subtracting a string or multiplying a string, things like that just don't make a lot of sense. So we can add strings, but we can't do any of the other stuff. But with numbers, we can do all these math operations. Case sensitive, no distribute. Okay. This is actually into the week 2 stuff. Two other things for the week 2 stuff. This Zoom is actually fairly short because weeks 1 and 2 are actually very simple. It does get more complicated as we go along. So let's talk about user input. Also, some of the stuff for week 2 is user input. And you have to use user input in your assignment, right? For your assignment, you have to have the user type in how many papers they delivered and some other stuff like that. So how do we get input from the user? Well, we need to think about string input and number input. So let's say I want somebody to type in their name. And here's how we get them to type in their name. We have a variable is equal to, we have this word called input, and inside the input is, you need to put what we call the prompt, is what do you want to display to the user so that they know they're supposed to type something in. We're going to put, what is your name? And then we're going to print out the name. So what's going to happen here? So this input tells Python, we want the user to type something on the keyboard. This is what it's going to display to the user so that they know they're supposed to type something in. And you need to make this descriptive, right? You need to tell them, you need to tell the user what you want them to do. And then after they type it on the keyboard, Python is going to make this variable equal to whatever they typed in on the keyboard. And then we're just going to print it out to see if it worked. So let's run that. So there you go. It says, what is your name? I'm going to put Dan. And then it prints out Dan because that's what I typed in. If I run it again, and just put Mike, it's going to say Mike because that's what I typed in. Let's have a little bit more fun with it. Say Mike is, well, name is a great name. Here we're adding strings, but we can do that. And so I'm going to say whatever the name is you typed in, I'm going to print it out plus tell you it's a great name. Let's save it and run it. Of course, we're going to say Dan this time. Dan is a great name. So here we have gotten some kind of input from the user. We've let them type something in. And then whatever they typed in, we're using it in our program. We're using that value. So by default, input gives us a string. What I mean by that. So even if we say, let's call it num, and we say type in a number, and then we're going to print the num. What happens here? So let's run it. We'll say 78, and it gives back to a 78. But here's what I need to ask you and what you need to think about. Is this number, is it the mathematical number 78? Or is it the text, the string 78? Here's one thing we can do. Let's try to subtract something from it. Remember I said you could add strings together, but you can't subtract strings, but you can subtract numbers, right? So let's just say C is equal to the number minus 5. Is this going to work? I know what the answer is. Do you know what the answer is? So that's right. It's not going to work because input gives you a string. And so even if I type in 72 on my keyboard, it's actually going to give to me the string 72. And so this number.
Does that have anything? Sorry.
Go ahead.
Oh, does that have anything to do with the fact that type in a number has the quotes around it, so therefore it's automatically not the number, but it's the character?
Nope. You have to put these quotes around this because this is a string. All strings will have these quotes around them. And this is a string that I'm saying, this is what I want the computer to print out. So that's why it's printing out, type in a number right there, because I told it this is what I want it to print out. So this being a string here, it doesn't have anything to do with what this num value actually is. But I am going to explain to that here shortly. But I just want to show that this is going to fail. Let's run it. Type in 72, and it gives me an error. And let's actually read what the error says. This is good practice for when you're doing your assignments. Is, you know, if your program fails, especially if it gives you like all this error information, if you actually read what it says, it'll tell you exactly what's wrong with your program. So it says in the file.py, and that's the file I'm in, on line 2. Oh, so my error is right here. It says, you know, that's what the line is. And unsupported operand for subtraction. So it tells me I'm trying to subtract a string and an integer. And you can't do that. With numbers, you can do any of the math operations. With strings, you can add, but you can only add one string to another. And I mean, if I put a plus here, that's a string plus a number. That's still going to fail. Because you can only add a string to a string. So whenever I take this string and try to add a number or subtract a number or anything, it's going to fail and give me an error. And that's because every time, whenever you do input here, it always gives you back a string. This variable will always be a string. But we can fix that. So let's say we want to make a calculator program and we want to add two numbers together, right? So we'll call this num1. Let's get another number called num2. We'll make a simple calculator. You're just going to say enter the first number that you want to add, right? And enter the second number, right? And they'll say answer is num1 plus num2. So this isn't quite right yet. I want to show you, what this gives you and how we're going to fix it. So if I type in a 5 and I type in a 3, what is the answer going to be? Remember, this is a string because it's coming from input. This is a string because it's coming from input. So if I type in, say, 15 for the first number and 65 for the second number, it gives me 1565. That's not exactly a good calculator, is it? But my program did exactly what I told it to do, because I put in 15. So num1 is the string 15. Num2 is the string 65 because that's what I typed in. And so I'm adding the string 15 and the string 65 together. And when you add strings, it just combines them and puts them against each other. So my program did what I told it to do, but it's not what I wanted it to do. So we need some way to take this string and convert it to the actual number it represents. We can do it like this. Say num1 is equal to the int of num1. We do the same thing with num2. Let me type it in and I'll explain to you what's going on. Actually, let's run it real fast and show you it works, and then I'll explain to you why it works. So 11, 22, and the answer is 33. And now we have a much better calculator, right? And you'll need to know this for your assignment because, like I said, for your assignment, you have to you have to type in how many papers you delivered or something like that. And so you need to be able to convert that from the string they typed in into the actual number so you can do some math with it. Okay. Yep, go ahead.
Is there anything wrong with doing the integer followed by a parentheses, then input, and then doing the prompt? Is there any benefit to doing it this way or the other?
Nope.
Okay.
This is, and I'll leave it like this for number 2 so you can see both of them side by side. This is actually much more concise. If I was programming a real assignment, I would actually do it like this, because right off the bat, if I'm reading this code, I know that this is going to be an integer. Like if I look at this, if I don't see this other line for a while, if I just see this, it's a little ambiguous as to whether it's going to be an actual number or a string. I mean, it is a string. Maybe later I'm going to convert it to an integer. I don't know. But
you could essentially convert that to the integer how you're doing it in the first suggestion.
Yeah.
Is that kind of
both of these things right here accomplish the exact same thing. And if I was coding up some real code, I wanted to run something, I would choose this right here for style reasons. It makes it much more evident it's going to be in the integer. Okay, so this works, right? So we type in numbers and we get the numbers added together. So much better calculator, right? So what's happening here is whenever I input, this is always a string, no matter what. Every time you do input, it's a string. No matter what you type in, you can type in some spaces, You can type in special characters. You can type in just numbers, letters, and numbers. Whatever you type in, it'll just be the string representation of whatever you typed in. Now, here, we're going to say, okay, string representation, I know you are supposed to be a number. And I want you to be an integer. And we'll talk about the different numbers here in a second, the different kinds of numbers. So I know this represents an integer. It's a string, but it represents what an integer should be. So this is going to convert it to the actual mathematical value of what you typed in. And there's a good way we can see this. So we're going to print out something called type of num1. We'll leave the rest of the stuff in there. So here we're going to say num1 is equal to what you type in, and then we're going to print out what the type of num1 is. This will tell us, is it a string? Is it an integer? Is it a float? Is it a lot of other complicated things we'll get to later in the course? But it'll tell us if it's right now, we just need to worry about string, floats, and integers. It'll tell us which one it is. Then after we do this, we're going to print out the type again to see what is it now. Let's run that. There you go. So after we typed in 11, it tells us it's a string, an str. And that's right, because right here, it is a string. Then we do this conversion, and then we print out the type again. And now it is an integer. So this is how we can convert whatever the number you type in, convert it from a string to the actual numerical value. So then I ask you, what if I type that in? What if I type in something that is not a number? But in my program, I'm still trying to convert it like it's a number. Error. And that's because it's telling you it can't convert this to a number because this is meaningless as a number. So whenever you do this, you need to make sure that what you're typing in is actually a number, or your program's going to crash. For your assignments and stuff, I'm not too much worried about you dealing with this. For your assignment, you can assume that if you tell me to type in a number, I'm going to type in a number. So whenever you ask how many newspapers I delivered, you can trust that I will type in an actual number. You don't need to worry too much about this error, but it's good to know it exists. So if you see this happen in your own program, you'll kind of know what's going on. All right, last thing I want to mention about these conversions here, this integer. So let's take those away. Let's just do the integer again. Let's show it still works. Still works. What if I type in that? Well, that's a number, right? But is that an integer? Now, you think way back to some of your math classes before, I don't know how many years ago for some of you. But we have basically integers and floats, right? Or I think they're more commonly known in math classes as decimal numbers. But in computer science, we call them floats, short for floating point numbers. But this is a floating point number because it has a decimal in it. But in my code, I'm still trying to say it's an integer. Error. Really the same thing. It's saying that it can't convert that to an integer because integers don't have decimals in them, right? Again, it works if I use integer numbers, whole numbers, that works. But as soon as I start trying to use a decimal, it doesn't work. But what if I wanted a decimal? So let's make a calculator, and this will be the last example we kind of go through on user input. And then I'll mention some things about the assignment, and then we'll let you guys ask questions. Let's make a calculator to to calculate the area of a circle, right? What's the area of a circle? Like area is pi times the radius, right? Pi r squared. That's the formula for a circle, right? So let's compute the area of a circle. So first, we need to get what pi is. We don't need to ask the user. Pi is a constant. We know what pi is. But let's get the radius from the user. Radius is the input. Enter the radius. For right now, let's leave it as an integer. Let's compute the answer is pi times the radius. And then we will print the answer. So now we have a calculator to compute the area of a circle. So let's run that. There you go. Enter the radius. Radius is 3. And that is the area of the circle. You can put that in your calculator and figure it out. That's right. Put 1. Then it's the same as pi, right? If the radius is 1. The radius is 2. It's like 2 pi. Oh, no, it's more than that because the radius squared, right? But there you go. So we have a program to compute the the area of a circle. But let's say this is feet, right? So when we're computing the area of a circle, let's say we have a circle that's 10 feet big, right? The radius is 10 feet. Okay, what if the radius is 7.5 feet? 7.5 feet? Oh, error. And that's because I said this is going to be an integer, but I didn't type in an integer. I typed in a float. Well, we can use a float here instead. So what R will be, R will not be an integer. R will be a float number. We're saying whatever we type in is going to have a decimal in it. So now if we run it with 7.5, it works. So with the numbers that you input, if you know for a fact that they have to be a whole number, use an integer. If you know they can be a decimal number, you want to use float there. So in your assignment, where you're typing in how many newspapers did you deliver, that makes sense to have an integer, right? Because you can't deliver 100.7 newspapers. No, you deliver a whole number of newspapers. So that makes sense to make it an integer. But if you're talking about the radius of a circle, the radius can really be any number, any decimal number, right? It doesn't have to be just a whole number. So that makes sense to make it a float. So that's when you would use one over the other. And if you want to keep it as a string, then you don't have to do anything special in your name, right? You don't have to do anything special here if you want it to stay a string, because it starts off being a string. It's already a string. All right. Last thing we'll mention is comments, because your code does have to be commented. And what do I mean by comments is whenever you are programming lines in your file, you need to put some kind of explanation about what it's actually doing. And so if I was making comments for this program, first of all, a comment starts with the pound sign, right? That means whatever is on this line, it's not actually code that's going to get executed. It's just text for me as the programmer to remind myself about what's going on. So at the beginning of the file, I'm going to make a comment that says, this is a program to calculate the area of a circle. That's kind of what the program does. So then we're going to put, so let's comment each of these lines. So here we're going to say, set the constant value of pi, right? So we're going to say this pi variable is equal to what the value of pi is. So that makes sense as comment. Let's comment this next line. And the comments go before the line that they represent. All right, so for this one, we're going to get the user to input the radius of the circle as a float. That's a very descriptive sentence of what this piece of code is doing. Let's comment this one. Compute the area of the circle with the formula a equals pi. Where's r? R, we'll use this, squared. Pi times r squared. If you remember from when we showed the operators, remember this means exponent. So we're going to say r to the second power, which is r squared, right? So this is the area pi r squared. So we're going to say here, we're going to compute the area of the circle with that formula. So actually, let's make it match exactly. Let's do r squared, right? It's the same thing. Now let's comment the last line. Output the computed answer. There you go. Save it and run it. Still works just the same way it would as it did last time, because all of these lines that start with a hashtag are all comments, and they're a reminder for you about what's going on. And why are they important? They're important for several reasons. First of all, for this program, this is an extremely simple program, right? It's only got 4 lines of actual code, right? But imagine you're working on a program that has 400,000 lines of code, which a lot of your complicated software packages have hundreds of thousands or millions of lines of code. Windows, let's look at Windows lines of code. How many lines of code? So Windows 10, now granted, an operating system is very, very complex, but Windows 10 has 50 million lines of code. 50 million, right? So when we have 4 lines of code, it's pretty easy to remember what's going on and figure it out. And if I come back and look at it later, it's pretty easy, right? But imagine I had 50 million lines of code. You need the comments so you as the programmer remember what's going on for yourself and for others. Because let's say you were writing a program that had even 100 lines of code, okay? Then you get halfway done and then you go to sleep that night and you wake up the next morning, and later on that evening, you go back and try to code some more on it. If you don't have any comments in there, it may be difficult for you to pick up where you left off. So it's a reminder for yourself. It's also a reminder for other people who will read your code. Like I said, Windows has 50 million lines of code. All of that was not written by one person. If you're going to go out to program real applications in the real world, get a job doing that, highly likely you will be working on a team of programmers. And so the comments are really instructions to the other programmers that look at what you created to understand what you did. And let's say in 2 years from now, somebody needs to come back and fix a bug in your code. They will look and expect comments to be there to explain what is going on with the code. That's why comments are important. Okay, That is all the material for week 1 and week 2. So for your assignment, I've already talked about a number of things for your assignment, but really I've given an example of everything you need to do for your assignment. So for your assignment, you need to have the user type in how many papers they delivered, right? And that's an integer. And I gave you an example of having the user type in an integer on the keyboard and saving it and saving it in a variable. You can rewind and watch that part of the video again if you need to, but I've shown you how to do that. Then you need to do some kind of mathematical computations. Well, first, take one step back. Before you do the mathematical computations, you have to set specific values, right? Like I think you need to set uh, what your rate is. Yeah, you got to set what your rate is. You got to set the cost for each newspaper. Well, that's kind of what I did here with the pie. I didn't have the user type that in, but I just said pi is equal to that number. For your newspaper thing, maybe you do your rate is 5%, but you didn't see me do, but you didn't see that for me, right? So you got to do that, which we've already given an example of. Right here is the example of that. Then you need to do some kind of math. And we've already done the example with the math. We did addition, we did subtraction, we did multiplication, we did power. Excuse me. We did power. I don't think I demonstrated division, but division is the same way. So those are the things you have to do for your assignment. Get a number input from the user. I've done the example. Set variables equal to specific values. We've done the example. Do some kind of mathematical calculation. We've done the example. And then print out what the result is. Okay. So for your assignment, it is due Tuesday night by 11:59 p.m. Eastern Standard Time. So please get it turned in before then. If you turn it in after the deadline, there are late penalties associated with that. I forget the exact percentages off the top of my head, but if you look at the syllabus, it'll tell you what the late point penalties are. Also put it in one of the course announcements, what the rate is for the late point penalties. So please get your assignments in on time. Now, if you do poorly on an assignment, after I've graded it and given you back your assignment, this isn't just for this assignment, it's for all of the assignments. If you did poorly, you can go back and correct what you got wrong and resubmit it to have it graded again. However, late point penalties will apply to your resubmission. But if you did poorly and you go back and you fix everything, it's very likely, even with late points, that you can end up with a better grade. Okay. That is all I have to cover. So I'll go ahead and open it up for any kind of questions you may have. It can be on the week 1 and 2 material, or it can be later material if you really want to ask those questions. So the floor is open.
Yeah, I've got a question. Would it help if I shared my screen, or do you not want to do that?
Yeah, I mean, if you need to, you can go ahead and share your screen. I think you should have permissions. Just let me know if it doesn't let you do it.
I think can you see my screen? Is that up? Okay. Is that, can you see that? Sorry. Okay.
I did see your screen for a second, but it's gone
I'm
now.
yeah, I somehow you got muted. I don't know if I did that. I'm sorry if I did. Can you hear me still?
Yes.
Okay, sorry. All right. Yeah. So on my output down here, when I was first doing this, I noticed I kept getting an error because I didn't have the string command attached to this, and I went back and I was listening to the other PowerPoint that's in the learning resources, and I noticed that he had a similar thing that went along the lines of this, and that he had the string attached to it. My question is how come when I take that out and if I do plus comma, how come that still gives an error?
So if you just take out the and I should have shown an example of this. I didn't think about doing it. So that total salary variable, that's a number, right? So
Right. It's yeah.
right. So
Oh, okay.
if you do not have the string there, then what you're trying to do, you're trying to add a string and a number together. You're trying to add
Okay.
your weekly salary is whatever. Yeah, if you just no, leave out the comment for a second. Leave out the comma for a second. If you just
Okay.
have this, you're trying to add a string to a number, and that doesn't work. That will give you an error. Okay.
Okay.
Now, if you want to use the comma separation, look at your first line there of prints, and what is the
This
difference
one.
you see? Yeah. So go ahead and put your comma for the other lines. Now, what's the difference
Okay.
between your first one and the other two? You have a plus. You have
Uh,
a plus sign in there.
that's okay. Right. Right.
So
All right.
you're
I
trying
think
to
I
say,
if I were to take
yeah, you're
right
trying to say take the string and add it to what? Nothing, right?
whatever the total right. So if I were to take these plus signs out, that would
That should work just
I would
fine.
essentially without and I wouldn't have to do the string, the plus
Correct.
string then. Okay, okay. So either way is fine. It's just a different way of getting to the
Yes.
end result essentially.
Yep. Either
Okay.
way, sign. What that str is doing. So just like in the example, and like you have in your code, where you have like an integer and then the input, you're taking the string and
Mhm.
converting it to an integer. Well, when you have
Right.
the str on the outside, you're taking whatever's on the inside and converting that to a string.
Okay. So when on the inside you mean what would be it here? What would the answer to that
Yes.
be? Okay. Okay, cool. Right. Yeah, that totally cleared it up for me. And that makes so much that makes sense because that plus sign is essentially it's
Yep.
doing this the
Right. Python is waiting for you to tell it what do you want me to add this to? But
okay, cool. All right. I think I'm good on that. I appreciate it. Thank you so much.
okay. All right. Anything else from anyone? All right, we'll go ahead and wrap it up. I do have this recorded, and we'll get it posted up later on so you can review anything you may have missed earlier. Did you have something else to add, Brian?
No, I think I'm good. I really appreciate it. That was really helpful.
Okay, no problem.
All right.
All right, everyone have a good night.
Have a good night. Thank you.